Hello to anyone who is unfortunate enough to be watching this presentation. My name is Ethan Horton, and here is my presentation on light and everything related to it. Defining light is actually quite simple. In physics, it is defined as the electromagnetic radiation that can be detected by the human eye, or is measurable. We have a scale for that. The part that is detected by the human eye is a much smaller section of the actual electromagnetic spectrum that we cannot see with our eyes, but we can actually, in fact, detect with instruments. Electromagnetic radiation can have wavelengths that can be measured between 1 times 10 to the negative 11th meters, which is gamma rays, really, really high frequency, really, really small, very, very toxic to humans, and can be measured up to several meters long to even outscaling buildings such as radio waves. Visible light is a much smaller section of this scale, taking up between 400 nanometers and 700 nanometers. Violet being on the shorter side, red being on the longer side. Just adjacent to either side of the visible light scale is infrared light and ultraviolet light, both just out of sight. The speed of light in a vacuum is an astronomical 299,792,458 meters per second, or for those of us who don't live in England or have to think really, really hard to understand meters per second and translate it into what we know and understand, it travels at a staggering 186,282 miles per second. There's the formula to figure out the speed of light, as given in physics. Actually classifying light as in what is light, answering that question is actually quite hard. There's not a single way to answer it. Physicists look at the physical properties as in what can it do, what is it made of, what actually reflects the light, where an artist will look at the aesthetic properties as how does it reflect off of this, how does the shadows look this, how does this change the colors of the world around me. Through sight, no matter how you view it, light is how we perceive and live in our world. Sunlight, which everyone understands as to be coming from the sun, illuminates the earth, warms the earth so we can see and live, determines weather patterns, and initiates photosynthesis, a very key attribute in actually living. Without photosynthesis, there would be no plants making oxygen or providing food to smaller animals that feed us. Light provides a window on a cosmological and atomic scale. Light is a window to a majority of the world outside of our other five senses. Almost all information from the rest of the universe is received through electromagnetic radiation. Interpreting the radiation, astronomers can glimpse at the earliest epochs of the universe, the very beginning of the universe, at the Big Bang, measuring the general expanse of the universe since, and determining chemical composition of stars and interstellar materials of our universe. Relying on light, telescopes expanded our universe, making us so much smaller than what we ever thought we could, and helped us realize that we are, in fact, not the center of the universe. Where microscopes made us so much larger than what we ever thought we could have possibly been, and made every aspect of our life, giving everything that much more detail, going into cells or even into atoms. Thanks to modern physics, light can be viewed more correctly as it is, as a ray, rather than what it was believed to be in the 1600s, an accumulation of particles that actually are, I'm blanking on words, are actually absorbed and are actually called to certain materials, rather than just going in every direction out of the source. Light is used in several aspects of the science field. Quantum mechanics can become visible by observing the frequencies of light emitted and absorbed by atoms as it passes through, as well as it's being passed through, refracted, diffracted, reflected, all of the above. Photochemical reactions had immense help from studying atomic and molecular spectroscopic tests, providing ultra-sensitive observations in both regions. Light transmits spatial and temporal information, as has been briefly explained through this presentation, creating a basic property for optics and optic communication, as well as an entire book, if not series of books, of related technologies. Some light manipulating technologies include lasers, holographic technologies, and fiber optic communications. Here is the electromagnetic spectrum from gamma rays all the way through radio waves. As you can see, radio waves are about a meter long. The reason it's measured in meters is because the rest of the world runs on the metric system rather than America, like the imperial system. And gamma rays are much, 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 much smaller. As you can see, the smaller it gets, the more dangerous and radioactive and toxic it gets, such as X-ray and gamma rays, and to the left, the larger it gets from visible light, the more tolerable it can be, which is why we can listen to radios all day long and use the microwave as much as we want, and can only have an X-ray about once or twice a year. Thank you. That was my presentation on light. I hope you enjoyed it. I hope, more importantly, you learned something, as I did, learning about all this information to create the presentation. I hope you viewers have a nice day.